Hello there guys, welcome back to another epic inexorable maths video. In this one we're looking at this summation here, trying to find a closed form for this. So this is the sum from r equals 0 to n of r times n choose r. Now, one thing that we have to do is recall what you call the binomial theorem, which hopefully everyone should know, even if you don't know it like this. This is basically just the sum of every term in the binomial expansion. It's equal to, in this case, a plus b to the power of n. We're going to use that in a second, not now though, so just keep that in the back of your head. This involves a very clever trick involving differentiation. I think it's a really cool question, but it's not one that's very obvious, so obviously don't be too disappointed if you can't see it. I didn't see it. I learned about this the other day. I think it's really cool. So what I'm going to do is I'm going to rewrite this thing involving a derivative. And to do that, what I'm going to do is I'm going to rewrite my sum, again, from r equals 0 to n of r times n choose r. And I'm going to add this extra term into it. And I'm going to add in x to the power of r minus 1. And you might say, hold on, how are you allowed to do that? I'm going to do something very sneaky. I'm going to put all of this in brackets. And I'm going to actually evaluate this when x is the number 1. So hopefully you agree that actually that is allowed, because I'm just saying I can put this here as long as x is the number 1. In the meantime, I can kind of play around with this. What I can do is I can rewrite this as the derivative of something, and that's why I've chosen to do my x to the power of r minus 1. You might notice that combined with the r, you've got r and then x to the r minus 1. That kind of looks like the derivative of something, and in fact it absolutely is. So I'm going to rewrite those terms involving a derivative. So the r and the x to the r minus 1, that is the derivative with respect to x of x to the power of r. And then I've also still got n choose r on the end. Okay, that's obviously a constant with respect to x. And again, I need to make sure that after I'm finished playing around with it, I do need to evaluate it when x is the number 1. Now what I'm going to do is I'm going to take this derivative to the outside, which I'm allowed to do because the only time when you have to be careful when you take a derivative to the outside is if you've got an infinite sum or if you've got some sort of divergent situation. But for us right now, we're absolutely allowed to take the derivative to the outside. It's just we're adding up a bunch of derivatives. Instead, we can just add up a bunch of stuff and then equally, individually take the derivative of each bit. So there's absolutely no problem with doing that. So this is the derivative with respect to x of the sum from r equals 0 to n. And the only thing left there is just n choose r. And then I've got my x to the r as well. And I'm going to close my bracket. I'm going to do an extra bracket around here. And then I can evaluate it again when x is the number 1, okay? Now, this is where we're going to use the binomial theorem, guys, because notice that actually this thing here is going to involve the binomial theorem, because I can just think of a as the number 1 and I can think of b as x, right? You can see here, if I let a be the number 1 and if I let b be x, then right here I've exactly got that. So I've got 1 plus x to the power of n there. Let me write that down. So I've got the derivative with respect to x of, and again, using the binomial theorem here, this is just 1 plus x to the power of n, okay? Close bracket on that, and then evaluate it at x equals 1. So kind of the final main step here is to actually differentiate 1 plus x to the power of n, which we know how to do. We can use the chain rule for that. So using the chain rule, we're going to have n times 1 plus x to the power of n minus 1. And if you times by the derivative of the inside, that's just the number 1, so there's nothing going on there. And then we have to evaluate this when x is 1. And then we're basically done, guys, because we're just going to plug the number 1 in and we're finished. So this is equal to n times 1 plus 1, so n times 2 to the power of n minus 1. That's the answer. So this sum is equal to n times 2 to the power of n minus 1, like that. And that's all there is to it. So a really, really nice way of finding a closed form expression for this sum. Sums are normally quite difficult to find closed forms expressions for. So it's really nice that we've got one for this. And I think the method is super cool, using binomial, using differentiation. Very cool question. Anyways, guys, please do like, share, subscribe, do all of that good stuff if you enjoyed the video. And I'll see you in the next one. Cheers.